Hey there, class. This is conic sections, chapter 13. There are 4 conic sections, so there are 4 sections in this chapter we're going to talk about. Circles, ellipses, hyperbolas, and parabolas. This really cool cone right here, kind of a cone facing a cone, like an hourglass idea. If you can imagine that, which has some great practical applications in general and special relativity and modern physics. Anyway, if you were to take a samurai sword and just swing through exactly parallel and cut through either the top or the bottom cone, you know what shape you'd end up having? A circle. But if you were to slice that at a slight angle, either up or down, just a slight angle, then it would end up being an ellipse. Let's say that you're able to slice down exactly parallel to the edge, maybe right down through here, or maybe up through here. You'd only hit one of the cones, but you'd never hit the other side, so you'd end up with this parabola type thing. Or if you were to slice exactly vertically, you'd hit both top and bottom cones, and that would end up giving you the hyperbola. Hyperbola and parabola almost looks like it's the same, except this is 2 parabolas. It's not. These hyperbolas eventually become almost straight diagonal, whereas a parabola, eventually, they're almost vertical. They're growing so fast. So there is a fair bit of solid shape difference between them. All conic sections have the idea that there is this x and y both squared idea. Maybe not exactly for the parabolas, but the circles, ellipses, and hyperbolas, there's an x squared and a y squared term. Specifically for the circles, what does the general equation of a circle look like? Well, if it's centered at the origin, it's going to be x squared plus y squared equals r squared. But if it's been shifted at all, if you shift that center any other place, then you just take care of that shift, just like we did parabolas. Remember, it was x minus h squared plus k. Well, that minus h has to do with that horizontal shift. It works the same way here. If we subtract h from our x, maybe we can subtract the k from the y, and that gives us our h, k, center, and r. So if I actually jump to example 2 instead of doing example 1 first, do you see this equation right here? Do you see that I am subtracting something and subtracting something? So I can end up figuring out that my center is, what I'm subtracting is 5. What I'm subtracting is a negative 3, and that is my center. What is this thing? This is a squared thing. I find the radius by square rooting. The square root of 6 is the square root of 6. So this ends up, which is about, 2.5, somewhere in there. So I could graph this, if I so chose, to realize that my center is 1, 2, 3, 4, 5 over, down 3. There's my center, and a radius of about 2.5. This right here is the graph of this equation with that center and radius. Let's see if we can go about building an equation knowing the center. Well, again, it's x minus h. What am I subtracting? I'm subtracting negative 3. What am I subtracting here? 2. And what am I squaring? 7. So we can clean this up a fair bit, and we end up finding out that minus a negative is the same as plus, and 7 squared is 49. So this right here is my equation, and I could graph that one as well in a very similar way. The MathX, the MyLab circle, hopefully you've figured out how to graph those. I don't know if there's a whole lot of graphing that you've had to do. Now, what about something like this, though? This is just a mess, because I don't see it in the nice, pretty form to be able to just pull the radius from this. Well, what I've got to do is I've got to separate the x's and y's and do some completing the square. So let me let me separate the x's and the y's for us. And I'm going to write the x's first. This is x squared minus 4x, and I'm going to leave some room. And then plus y squared minus 8y, leave some room. And that's going to equal, I'm going to throw my minus 16 and add 16 to both sides, so I have equals 16. Now I've got to figure out how I'm going to fill in those blanks with the idea of completing the square. Well, this minus 4, take half of the minus 4, that's negative 2, square that, you get 4. So I'm actually going to add 4, and then add 4 to the other side to keep it balanced. Here, the minus 8, what's half of negative 8? Negative 4. Square negative 4, what do you get? That's 16. So I'm going to add 16 here. And now we're going to see that this thing completes beautifully as the square root, same sign, squared, plus square root, same sign, squared. 16 plus 4 is 20, plus 16 is 36. Ah, wow, look at that. Now I can see what I'm subtracting, and what I'm squaring. The center is 2, 4. And if my r squared is 36, my r is the square root of this, which is 6. So I found my center and my radius thusly. So that's circles. Come back and take a look at ellipses next.